Tell me if
now I see your shoulder.
Okay, that is just enough for the interview, right?
Yes. Okay.
Well, Jose, all right. So this is perfect. Where shall we start? Because there is so much information about how a technology can be successful. In this case, in the United States, it all started somewhere, right, Jose?
Yes. Well, we can start by the beginning. Actually, the technology had been successful in many countries around the world, so it was not anything new back in 2009, as you know. But it was actually new in North America, not only the United States, but also Canada. For a number of reasons, the certification requirements for radios in both countries were not compatible with the TETRA modulation. So that was a serious inconvenience because it doesn't matter how good the radio would be, you go to the lab and it is not compliant with the emission requirements in either country.
And then you need to go back.
Yes, so you take the plane back to Europe and they say, okay, I'm sorry, but we cannot do this because we cannot get type acceptance, and without type acceptance, there is no way. So, at that point, we started considering how could we possibly make the TETRA spectrum compliant with the emission requirements.
Because those requirements were different than in Europe and other places around the world?
Completely different, because, in all the countries in the world were the same as in the US and Canada. But in the rest of the world, the requirements were updated previously, but not in the US or Canada. They kept the old certification requirements, which essentially is about emission masks. And that has to do with how the spectrum looks like. It is not about how much energy are you going to radiate on the adjacent channels. It is about the shape of the spectrum.
And why didn't they update that?
Well, I suppose that because all the previously available technologies in the US and Canada didn't have any problems to fit the boundaries, to meet the boundaries of the emission masks, because the modulations were non-linear. So even though there were digital equipment available, for example, P25, Open Sky, and some others, digital technologies, all of them use non-linear modulations, meaning that they are actually analog radios with digital speech codecs. But the spectrum is analog, meaning that it resembles an analog radios. And that is why they didn't have any problem to meet the boundaries of the emission masks. But then one day we came up with TETRA, which is an entirely different concept, because TETRA is not only digital, it is a linear modulation. And so the spectrum resembles a table. So it's flat and then it drops very quickly. It is not like a typical shape of the analog modulations. And then the emission mask could not be met by a very narrow margin. It was, as I used to say, by the thickness of one hair. But it was not compliant. So you go to the lab and the equipment was rejected.
Rules are the rules, right?
The rules are the rules. Recently we have heard from someone in Australia that the rules are the rules. So what can we do? A few engineers in this house, we are in Zaragoza, Spain. This is Teltronic, Powertrunk's parent company. So a few brilliant engineers came up with a solution that, well, how could we compress slightly the TETRA spectrum in a way that it is still operational? So we don't want to lose performance, because if the radio does not perform, so we are going nowhere. Of course, you can always compress spectrum, but if you do it in a way that the radio doesn't work, so there's no business.
But it was only a hair-thin change that you need to do.
Very slight, very slight.
Yeah.
So the solution happened to be one of the parameters of the TETRA modulation, so-called alpha, which is actually something that conforms the signal at the amplifier, the output filter. So changing the value of this alpha parameter that the TETRA standard mandates that must be 0.35, then these guys found out that using 0.2, then the spectrum got compressed. Yet the operational capabilities of the radio were kept. So with this implementation, then we went to a lab, of course, FCC certified lab and Industry Canada certified labs, because both rules were practically the same, Canadian and American rules.
Yeah, you wanted to have the North American market, so you go to Canada
both
and the US,
type
of course.
acceptance certificates in the US and Canada. So we went to a lab, and at the lab they said, okay, yes, this one is compliant. So we got FCC and Industry Canada type acceptance with this modified version of TETRA.
Where other manufacturers just took it for granted that they couldn't be able to, they would not be able to implement TETRA in the US, you thought, okay, let's take, that's the starting point from you.
Yes.
To see what is possible, how can we change things without changing them too much?
Well, it was a different approach because other manufacturers tried previously, a few years before, to introduce TETRA in North America. But the approach was, well, given that we cannot comply with the existing emission requirements, so we are going to request that the emission requirements are changed. So we go to the FCC or we go to the TIA, the Telecommunications Industry Association, and we propose that they change the rules to make TETRA available in North America. That was the approach. Yeah, it was since as early as 2000.
But is that normally the way you ask an organization to change the rules? Do you do that often in other countries around the world, if it's necessary?
No, we never needed to do that anywhere else.
Okay.
So it was only in North America, because all the other countries had changed the emission rules much earlier, even in the 1990s. In some cases in the 1980s.
And there was no reason for the organization to change the rules, probably because there was never a request.
Exactly, nobody requested the rules to be changed. But of course, if you file a request for a waiver or a petition for the rules to be changed, then you immediately face serious inconveniences because normally the response is very slow. There are lots of explanations to be given. Why do you want to do this? On what grounds do you think that we need to change the rules? So it is not as simple as saying, hello, I am Jose, and I would like you to change the emission rules in the United States and Canada, as you can imagine. So that takes very long, if ever, because of course there were many people quite unhappy at the idea of introducing TETRA in North America.
Because it's predominantly P25 country, right? Yes,
well, TETRA is a new kid on the block, more competition, and nobody likes more competition. So what we did was, okay, instead of arguing, because arguing takes long, it is always very hard, not clearly successful, at least in the short term. So we decided to take a different approach. Okay, we are going to meet the existing rules. So we are not going to file a petition for the rules to be changed. So we are going to change our equipment to make it compliant.
And was that also shortening timeframes of decisions? Because that made it much faster to enter the technology in the US.
Exactly, because time to market was of the essence. And so once you are compliant and you compress the data spectrum and you get type acceptance, then you can start immediately quoting the radios, quoting the solutions, bidding upon RFPs. And that's exactly what we did. In Canada, it was a very smooth process. And there was a customer interested in British Columbia, the electrical utility, BC Hydro. And then they understood, we proposed our modified version of TETRA, which we called TETRA Interoperable DLMR. That was the name. Well, I invented the name because we needed to give that thing a new name. It's okay, this is not TETRA, this is TI-DLMR. And they understood that, okay, we are going to award you the contract. But then immediately they called Industry Canada that, okay, you know what, we are awarding a TI-DLMR contract. But we would prefer that if we're going to award a TETRA contract. So we need you guys to amend the existing emission rules. And Industry Canada did it immediately. So all the frequency bands, they changed the emission rules to adopt ACP, adjacent channel protection, which is the criterion used everywhere else in the world. So the Canadians did it very quickly. But then the next step was RFP in New Jersey with the transit agency, New Jersey Transit. They were interested since a few years before in our TETRA solution because they knew that TETRA provides a superior data throughput.
How were they interested in the first place? Did they meet you at an exhibition or
Yes. But they were interested previously since at least 2005. They heard about TETRA and they were interested, but the problem is that TETRA was not available in the US because of this emission issue with emission masks. And then the moment they learned that we gained type acceptance in the US with TI-DLMR, they became immediately interested. And so we conducted a pilot with a couple of base stations in New Jersey, integration with an existing dispatch system, and everything worked flawlessly. And they experienced TETRA's speech quality, which is outstanding. There is nothing comparable. Other technologies cannot be even compared.
Even P25, APCO 25?
No, with P25 you will never know whom you are speaking with. You cannot recognize the other person's voice on the radio. Okay. TETRA provides cell phone-like speech quality.
So but then I would say that it's time for TETRA to be accepted by public safety as well. But that didn't happen, right?
But that comes later.
Okay.
At that time, 2011, so the first challenge was to get the first contract in the US. We had already one in Canada, but Canada is Canada and the US is the US. So how to get the contract in the US? Okay, what I have is TI-DLMR. And that was called by some other parties reduced power TETRA, low power TETRA, and things like that. But they understood, this is what I have. It is the same, almost the same as TETRA. Operationally, it is the same. But it is not 100% TETRA technologically. So this is a flavored TETRA. And then they said, okay, but this is good enough. So let's conduct some pilot in New Jersey and see what happens. So the outcome was extremely successful because TETRA's speech quality is far superior to any other technologies. And they were impressed. Well, actually, what they said the first time they heard a voice call with TETRA radios, they said, wow, this is like passing from black and white TV to color TV. That's what they said. So we want to move forward. And then they issued an RFP, and we were awarded the contract. But there were complaints. And the complaints were based on that TETRA was not allowed in the US. So there was a confusion. Going back and forth, official meetings with the Federal Communications Commission. Well, it is true that TETRA is not allowed in this country. And then at some point, I had to say that, well, I am happy to hear that, but what I am offering is not TETRA. Is something else. So this is not TETRA. This is TIDLMR.
And that was registered and approved.
Yes. And the evidence is that I have a type acceptance certificate because with TETRA, I couldn't have this piece of paper issued by the FCC. Yeah. So then NJT, New Jersey Transit, decided to move forward, and then at some point later, it was in September 2012, the FCC decided to amend the emission rules because there was no point. Well, this is my interpretation. In parallel, in 2009, the TETRA Association, Phil Kidner, the late Phil Kidner that has passed away so recently, he was very energetic about filing request for a waiver with the FCC to change the rules. So the petition was there over the past, at that point, 3 years. But then, after the evidence that an RFP had been awarded to a TETRA manufacturer with a flavored version of TETRA, my interpretation is that the FCC preferred to amend the rules, and because otherwise in the US there would be something that was not 100% standard. But that happened after the fact that the RFP had been already awarded. And then the FCC amended the emission rules in certain frequency bands, not all.
Unlike
the Canadians, which amended the rules on all bands, in the US everything was more selective.
Was there a reason not to allow it in certain frequency bands? A good reason?
Well, that would be speculative for me. Of course, there are theories. One of the reasons is that the TETRA Association requested the waiver just in some frequency bands.
And the TETRA Association is the TCCA right now, right?
Yes. Yeah. Later, the TA became the TCCA.
Yeah.
But it was the same. It was the TCCA, and the TCCA requested that only certain bands were changed, not all. Why did the TCCA do that? I don't know. I can only guess. But I am not in a position to speculate about the motives. But the point is that it was only 800 megs, certain portion of the 800 megs band, and 450, 470. And then the rules were changed, meaning that we could supply the 100% standard TETRA, not this TIDLMR anymore. However, we kept it for some other frequency bands. So at the moment, we are supplying TETRA, the flavor version, which is equally operational, for some other special frequencies that were never changed. I mean, the emission rules were never changed for certain subbands. So it is pretty complicated, even difficult to understand from a European standpoint. But well, the US is the US, and there's a lot of complexity about spectrum management.
And today you're able to address what markets exactly? Or what markets you're not able to address?
Well, after this award in New Jersey, we started addressing transportation and also utilities. There are many utilities in the US using the 450, 470 megs band, and also oil and gas and other industries.
Mining.
We found a customer in Canada at Nico Eagle company, and we supplied a TETRA system for a gold mine in the Arctic Circle, pretty cold place. Yeah. So we opened all those verticals, but we never addressed public safety because public safety is different. It is different frequency band, 700 megs. Nobody ever developed radios, TETRA radios in 700 megs, because that band is not used in any other country. So that was another inconvenience. And it was then we found, we met with MTA, the Metropolitan Transportation Authority, and in particular New York City Transit, which is even larger than New Jersey Transit. And they were interested in our TETRA solution. But the frequency band available was two blocks, one in 700, another one in 800. It's okay, 100 we have the radios already, 700 we don't. So we will have to develop TETRA in 700 megs. But then you find that the rules, the FCC rules in 700 megs require that all radios operating in 700 megs must be capable of operating on the nationwide P25 interoperability channels. All subscribers operating in that band. It doesn't matter if the end user is a public safety organization or not. So the requirement is about the frequency. So okay, so what can we do? Because we have TETRA in 100 megs. We are already supplying the radios in New Jersey, but we don't have TETRA radios in 700. So what we did is, okay, we will develop a TETRA radio with both bands, 700 and 800, in the same radio. And we will include the P25 protocol in the radio, so it is
compliant. Yeah.
Yes, through the user menu in the radio, the hand portables, you can select TETRA mode or P25 mode. And the mobile radio is the same. You can program the radio to be TETRA or P25, then it is compliant.
It's a very creative solution, right?
Yes, but once again, it was the same approach. It's okay, we are not going to request the government to change the rules. We are going to comply with the rules. And that is the only way you can be successful in the US. In La Mobile Radio or in any other business you possibly want to undertake in the US. You better be compliant with the rules, because if you are not, then you will never join the market. Nobody is going to make things easy for you, because it's a great country, you know? And so you need to be compliant. And so we followed the same approach. It worked, and there was we conducted another pilot with a base station in Manhattan and another one in Brooklyn. We tested handover that is not supported by our technologies, and they were impressed, and that you can be driving a vehicle moving, and then you can continue speaking as you are changing from the coverage of a base station to another, and the call didn't drop. That was very innovative. They issued the IP, and we won, because we have the radio 700, 800 TETRA P25 certified by the FCC. And so the other bidder was Motorola, and Motorola failed to provide type acceptance certificates. So it was very simple. This is public information. It is in the public domain. I am not disclosing any secrets. Everything is in the public domain in the MTA website. And for that reason, we were awarded the contract. So the interesting thing comes now, because once we have supplied those radios that are fully compliant with the public safety requirements, because for some reason New York City Transit is using public safety spectrum, their radios are compliant, meaning that we are offering actually TETRA to public safety in the US. A different thing is to find a customer willing to buy it.
But that's all good old canvassing and good old approaching of your customers, right?
It is legal. So meaning that we have the right to propose it, offer the equipment, and then it would be our job, that is a commercial job, to convince customers that TETRA is better.
And you have a lot of customers already in the US. We just went to the board, to the plant board over there. We saw some of them are not even there on the board, but it's very successful, I can say right now.
It is successful, and not only that, it is that all our customers are high-profile organizations.
Yeah.
So, but public safety is a different thing. Is a more difficult because there is another established standard, which is P25, which is dominant in North America and pretty much in South America as well. So it is never easy to row against the current, but we are confident because there is a clear fact that TETRA is better. I mean, speech quality, background noise cancellation, and data throughput. TETRA is clearly superior to P25 Phase 2.
And Jose, on the development and about technologies and about things, we can talk about this forever, but there is something you want to show me. And I see some radios on the ground there, right?
I have a few things here. We are now shooting back 46 years. This was the first radio developed by Powertrunk back in 1976. So this was hand portable for strong people, you know. And it is, well, you can test it. It is, well, not too heavy.
It's called Teltron.
Teltron. Yes, that was the first name of the company.
And a stubby antenna, well, flexible antenna.
Yeah, very flexible.
All right.
So this is a piece of artwork, no crystal controlled oscillator. So it was, this is ancient technology. Well, I'm going to open it for you. So you can see the kind of electronics that were used back in 1976. Yeah. Everything was practically artwork. Everything manufactured at home, including the PCB,
handmade.
Yes, even this transformer. Well, this is for the. This is the power supply. Yeah. Well, not so old because I am also old, and I remember these things when they were not old.
Yeah.
So that is so funny. And then I'm going to show you the hand portables of the 1980s. This one, 1983. This was the first with the crystal controlled oscillator. Yes, I think it was 1983, supplied by the fire department in Zaragoza.
Only 1983.
1983.
If you talk about it very quickly, it's not such a long time ago.
Yeah, no. For me, 1983 was yesterday.
Exactly. All right.
And then this one is smaller. This was quite successful. This is probably the late 1980s.
Okay.
It was very popular because it's smaller.
Yeah.
And everybody likes smaller radios.
Yeah. Talking about names, right? I see Teltronic on the devices. About the name Powertrunk, I always wondered where that name is coming from. There must be a reason for that name, or not?
Yeah,
or is it just a name?
Of course, there is a reason. When we first started addressing the U.S. market back in 2008. We received a letter from another company by the same name, Teltronic, which is registered in the US and Canada. And they said that, well, you guys unfortunately cannot use our brand name. And that is why we decided to use a new one. So the reason is that there was another company already registered by the same name.
But not in our industry, not in the industry.
Yes.
In the industry.
In our industry.
Okay.
Yes, it is system integrator and distributor, land mobile radio. So it is in the same industry.
Well, and they're using the name Teltronic
Yes.
like the Teltronic here in Spain.
Yes.
So they're very lucky to use that name.
Well, probably they are. Well, the point is that clearly we could not use our own brand name, Teltronic, in the US or Canada.
Yeah.
And then, okay, and what name can we use? So we organize a contest here in this building. We need the people to propose names for our new company in North America. And there were several proposals. One of them won, Powertrunk.
Okay.
I don't remember the other names.
Okay.
There were several names proposed, but this Powertrunk won.
Okay. But I believe there are still not many companies very active on TETRA in the US, right? You're really, one of the few.
Yes, there are other companies. What happened is there were certain acquisitions that made that companies that were competing now are part of the same group. For example, Sapura. Sapura was also active with TETRA in the US, but when Sapura took over Teltronic, then we were the same company. And DAN, for example, is also active
Yes.
with TETRA in North America. The other manufacturers are not. Well, Motorola has started already supplying TETRA in North America.
Has started.
Yes. There are a couple of cases.
Okay.
Yes.
But not that much.
Not that much. But they have already started. Airbus is doing nothing. Leonardo was active a few years ago, but for some reason they gave up. Okay. But MPC Orders, for example, is also supplying TETRA radios in TETRA modems in the US.
But understanding the market size in the United States on public transport, utilities, oil and gas, mining, I think there's still a lot of things to do, right, for you?
There are still a lot of things to do. I've been living in the US 13 years already, and I know that this is just the beginning, because the market is huge. So we need to continue moving forward because, well, there is already an inroad with high-profile customers, but there is also strong opposition. So I think that will be a job to be done by someone else in the future, because I don't have many more years left in my professional career, so I believe that someone else will have to take over and then to continue advancing. But clearly, there will be a benefit to the public interest, because TETRA is clearly the best LMR technology, and it is significantly more affordable than the competing technology. And when I say significantly, I mean a fraction of the price. So I think that there are legitimate reasons to continue moving forward with TETRA in North America.
Thank you very much for this interview. Much appreciated.
Thank you.